Dear friends, once again welcome. Let us discuss about homogeneous transformation matrices and why it is required to be studied. So our answer is because we want to know our location of our manipulator. So this is suppose a manipulator. This is the base of the robot and these are the links. Suppose L1, L2, L3 link and this is the AND effector. Now we want to know where is our robot. So what is the X, Y, Z of our robot? What about orientations? Like this theta 1 and this theta 2 and third one theta 3. So theta 1 plus theta 2 plus theta 3 means orientation of the manipulator, means the robot. So this is what? Where is x, y, z in case of 3D, x, y in case of 2D. Okay, so our focus is here now 2D. So this, for to know x, y, z of the robot, what we have to do? We have to multiply to know this. To know these means locations. Location of the AND effector. We need to multiply number of matrices. Means number of matrices means depends upon the number of transformations. Number of transformations. ठीक है, एक ट्रांसफॉर्मेशन में एक मैट्रिक्स होता है. So and in proper order and in proper order. Okay, so what should be like suppose we have two matrices. This is of 3 by 3 and one more matrix and it has dimension is 4 by 4. Okay, so how to multiply matrices? We know how to multiply matrices. So for that, suppose I am selecting the column of matrix 2. This is the one matrix, this is the second matrix. So what we have to do here, the number of elements of the column of suppose matrix here 2 should be equal to the number of elements of matrix, number of elements in row, first row. Okay, means we are talking about this one, this row. This is what? Row 1 and this is what? Column 1 of second matrix. So number of elements in row 1 of matrix 1 should be equal. Once again, the number of elements of the column of matrix 2 should be equal, must be equal to number of elements of row 1 of matrix 1. Then only we can multiply. So here, see, dimensions are matching. Here, the first matrix has dimension of 3 by 3. Second matrix has dimension of 4 by 4. So dimensions are not matching. So can we multiply? Here, the number of elements of column of matrix 2, that is 4. But number of elements in row 1 of matrix 1, that is 3. So both are not equal. So we cannot multiply the matrices. If we cannot multiply, then can we analyze the robot? Then can we analyze the robot? Means to know about variable manipulator, variable end effector, what is x, y, z coordinates, what about the orientation of the manipulator. This we cannot know. Okay. So then what is solution? Why not to make solution is here. So answer of this question, then can we analyze the robot? So answer is no. Then what is the solution? What is the solution? So solution is here to make the matrices, or to convert, to make or to convert the matrices into square matrices. And how it is possible? Suppose there is transformation like it is a 1 and a 2. So transformation, it is transformation of frame 2 with respect to frame 1. Okay. And it is a combination of, suppose, rotation about z-axis of 60 degree and translation like 6, 4, 3, and the order we are order may be anything. Okay. So what will be size of this? 3 by 3. And what about this? 4 into 4. So can we multiply? So no, it is not possible. Then what we do? So rotation about z-axis. So it is what we do here. So what we do here, there will be 9 elements in this matrix, and here 12 elements will be there. It is 4 into 4. So what we do here, and this will be obviously rotation about z, it is, so it is 1 here, and c theta means cos theta, then minus sin theta, then here sin theta, here cos theta. It is 0, it is 0, it is 0, it is 0. So what we do, we add one more matrix. So all corresponding values of this one element, row wise all elements 0, columns अगर देखें तो all column values 0. Okay, then it becomes 4 into 4 matrix. So what we did here, we added this matrix, means a column, and this row, and it doesn't affect in the result. Okay, it facilitates to multiplication. So that's why now we will be able to we will be able to multiply the matrices. Okay, generally it is in the form of t, and it is I minus 1, it is I is equal to, and this one rotation matrix, here position vector, so P position vector, and 0 0 0 matrix, you can say, yeah, this on last matrix. Okay, and what about the size of this R? 3 by 3. And what about the size of this P? So there will be 3 rows and 1 column. Okay, in this way matrix can be converted. Okay, but here in the rotation matrix, this actually, if you compare the translation matrix, here this one, so this one is the here it will be 6 4 3 1. So it is what? It is this column is the position vector, position vector. But here it is a pure rotation about z. That's why the last column, elements of the last column will have 0 except the this corner one, this one. Okay? So in this way, what is the transformation, what is the homogeneous transformation? So homogeneous transformation में क्या कहते हैं कि suppose we want to know about the location of the robot, so उसके लिए क्या करना पड़ेगा, फ्रेम असाइन करने पड़ते हैं, और हर एक फ्रेम में एक मैट्रिक्स बनते हैं, either due to translation, either due to rotation, or due to combination. And for each transformation we get one matrix, and we need to multiply together in different orders depending upon the means whether we need to pre-multiply or post-multiply. Okay, then if matrices are not in square, we cannot analyze. If it is in square, then we can analyze, and we can know what is the orientation of the manipulator, what is the position of the manipulator. And one thing, when to pre-multiply, when to pre-multiply. Yeah. So if transformations are performed with respect to the reference frame, then we need to pre-multiply. Suppose there is a point P and NOA, and some transformations are in order, like first rotation about z of some degree theta, then second one the translation of 1 3 5, then third one like again rotation about x with some angle theta. Then what will be the reverse of multiplication? Okay, means this third one, then here second one, then here first one. Okay, order of multiplication that is equal to reverse of transformation.